And now let's see the animation. It falls from the sky in frame 11, the first hit. Around frames 11 and 13 we see values changing on the sources. Around frame 29 they start preparing for the big explosion. Around frame 35 all emitters have the maximum rate values, and for 4 frames, I mean till the frame 39, sources emit particles with this maximum rate and we see the explosion. And in frame 46 the values come to 0. Let's see the melon pieces, I mean the low poly melon pieces. I will use Glu3D object manager now to give surface attributes. These will be collision gap 0.1, adherence 0, and let's say bounce is 50. And glass bottle can stay the same as before. Now I can start calculating the particle simulation. I'm flashing the cache, but don't forget to change the -1 value to 0, so our first frame will not be deleted. Now this particle simulation will take a few hours, so I will be back when calculations are finished. Yes, now calculations are finished, so let's see what happens. It falls down, and after the first impact we see particles coming out from the cracks. Actually they are coming out from the filled bottle, and you see these blue objects coming out from our sources. Yes, it hits the ground, bounced, sources start changing values. In the second bounce, when the melon breaks into two, all sources emit particles strongly, but I see some particles are in the melon object. Well, I think when source diameters getting larger, some part of sources gets in the melon object and they emit particles in the object. Another problem is we see an empty volume in the middle of the particle explosion. I will fill it later. As you see, because the sources are in the object, we see many particles are closed in the object. Actually I need them out, not in. I will move these sources out. We have to see particles out of these objects. Yes, now let's see the same animation from a different angle. I did not do any changes yet, and let's see from here. First bounce, small particles. Second bounce, melon breaks into two, explosion, particles move around. We do not have a floor object yet. So all particles are falling down to infinity. Next time I will unhide the floor object. Now I will move the sources. I will move them out in time from frame 0 to frame 36. They will move out slowly, so I will see many more particles in the air. In my next calculation, the number of particles I will see on the air will be very high. Unfortunately, I have many particles in the object now, and that's not a desired thing. Now I will not use these particle dummies anymore, so I'll freeze them so that I cannot move them accidentally. I'm making small changes. I'm moving frames which are located in 31 and 34 to one frame back, and other part one frame further. So this will create more particle emission, and I can create the second group of sources in the inner surface of the melon. These are about 30 sources. These will fill the volume between the periphery and the inner core. They will be on the melon surface, and let's copy them one by one. I have to be careful so that they will not be in the object. Well, save it, and I have to copy all sources on the other part also. These will be about 30 sources, I mean the total. I will copy one of them to inner part and copy it again. These two will create the inner and largest sources. The diameter will be 10 in the maximum emission time. This will be the largest in diameter and emission rate. Now, before simulation, particle thickness will be 2.5. Thickness of water is between 2 and 3, so let's calculate now. Yes, after the calculation we get this. Particles are moving around. We have a lot of fluid in the center. Sources on the surface are filling the volume between the inner core and the periphery sources. Actually, it is quite acceptable, but to see what is going on here, let's build the surface. I made a preview for this. Let's see it in real time. Now we are watching. You see, after the first impact we see drops moving out. When the explosion occurs we see a large volume of fluid, and after that we see fluid coming from the inner surface. It is quite acceptable. Yes, now I will calculate the surface. Surface level of detail is 10, drop size is 2.8, and melting threshold is 3.3. But these numbers are not finalized. I can change them in future. These are only a start. Yes. Actually, calculating the surface also takes Yes, now it is finished, but I think I have to make small changes. I think drop size is too small. I will change drop size and melting threshold to 4. Let's change surface level of detail to 5. Yes, we can see again. This process will take a lot of time. Let's see the start and watch the result. Yes, now it is finished, and let's see the preview. It looks quite good. But the sources on the inner surface emits too much time when they are at the maximum point, and this is not we want. So I will make a few changes and I will make that time shorter. Now I will delete all surface mesh calculations. The sources on the inner surface emits particles until frame 110. This looks too long. I will move the keyframe from frame 110 to frame 80. I have to do this for all emitters located in the inner surface. So now let's make the last changings. Let's make the bounce value of cylinder to 0, and let's make it also 0 for melon object. And let's make bounce value to 0.1 for bottle. So let's see what happened after the new calculations according to the values. Yes, I think it looks quite good. Now let's calculate the surface mesh. This will be a very long process, so let's see the finished result. Well, now this is what I want. This looks like juice. Maybe we can tweak more, but it looks okay. So now let's see the material. I applied ray trace material for the fluid object. Refraction index is 1.3, and it is, and the color is orange. A mixture of melon and orange can be orange color. Let's hide the animation and simulation dummies. and let's unhide the scene objects. And this will be a 220 frame long animation render, and it will take more than 1 day to render it. Yes, after 1 day of particle simulation and surface mesh calculation and 2 days of render, let's see the result. Maybe I have to buy a faster computer. Okay, let's play it. And here is the result. Now let's remember what we did in this project. We have found an idea, draw a storyboard, modeled the objects. These were orange, melon and a bottle. Of course, we modeled the collision objects, worked on the scene setup, created the animation with reactor, but we did not like it, so we created it again manually. After that, we created these objects, these ones, I mean the ones on the melon and on the bottle, by using P-wrapper, and we filled the bottle, and at last placed 70 sources to create the fluid explosion. I can still say something about this result. These are some drops of fluid are passing through the orange, so it will be better to add these objects in the collision list. And color of the fluid is too dark, I think, in some areas. In some parts it's almost black. I think this is related with the environment settings, and the drops on the melon are too much, I think. I can reduce them, and we see some extra inner refraction between the outer surface of the bottle and inner surface of the melon. And finally, it is better to put a label on the glass bottle. Now let me correct these issues and make a final full frame render. Now here is our final animation in full frame render. I have corrected the lacking points. Orange objects are added to the collision list. A label added, and here is the final result. Well, this is just an example to show how we can use Glu3D fluid simulation system in a production quality animation project. I hope I could help you to visualize the workflow of Glu3D, and I hope you enjoy working with me.